The dolphin is asked to identify which of the two is the same. The dolphin chooses the correct pipe. This proves that dolphins have the ability to distinguish fine details by using sound. An experiment using sonar was carried out to find out more about identification using sound. Sound is emitted from the round black part. The same part also receives the sound reflected from an underwater object. A cage is lowered in front of the sonar. This is an image looking down on the pool from above. The straight line on top represents the edge of the pool. The square cage appears in front of the pool edge. By measuring the time and strength of the reflective sound, the underwater object can be identified. This is known as echolocation. Dolphins use echolocation to explore the underwater topography and to find food in the sea. Just as we have our bodies diagnosed with echograms, dolphins are said to be capable of seeing inside their fellow dolphins. The dolphin's echolocation ability can even identify fish hiding in the sand. The dolphins possess an even more amazing ability. On closer inspection, the movement of the fish escaping from the sand is slow and labored. It is thought that the dolphin directs a powerful sound at the prey it detects and paralyzes it. Of all the marine creatures, cetaceans are the only marine mammals that can skillfully use sound to such a degree. Why did only cetaceans acquire this special ability to manipulate sound? The answer lies in its evolutionary history. This is a whale embryo. On closer inspection, its hind legs are visible. This shows that at one point in its evolutionary stage, the whale possessed 4 legs. Being mammals, cetaceans once lived on land. The key to solving the mystery of how the whale emerged lay hidden in the Himalayan mountains. About 50 million years ago, Earth had a temperate climate, and part of the Himalayas was on the edge of a shallow sea. And it was here that an unusual animal fossil was discovered. The fossil was discovered by the research team of Dr. Hans Thewissen of Northeastern Ohio University's College of Medicine. From the fossil, the team believed that the creature weighed 300 kilograms. Because of its fore and hind limbs, the animal was presumed to have walked on land. At first, the scientists had no idea what species the animal belonged to. But as they continued their investigation, they realized that it was a whale.
At that point, when we dug up the skull, we transported it back to the place where we were staying, which is a little rest house. And I took some fine probes and some brushes, and I cleaned off certain parts. I cleaned off the teeth, And then also at some point I cleaned off the ear, and then I suddenly realized that the ear of this whale, of this animal, was the ear of a whale.
This is the ear bone of that creature. It's part of an ear bone known as tympanic bulla. It's very hard, intricate, and thick. This tympanic bulla is peculiar to cetaceans. To find out what the ear bone of a cetacean looks like, a dolphin head was put through an X-ray CT scanner. The long jawbone can be seen clearly, and right behind it is the tympanic bulla. The ear hole of the whale is closed to prevent seawater getting in. For that reason, sound traveling through water is picked up at the base joint of the lower jawbone, and from there to the tympanic bulla ear bone next to it. The ear bone was removed and its cross-section examined. Its bulk structure can be seen. Because of this thickness, sound that reaches the jawbone is efficiently conveyed from the inner ear to the brain. Analysis showed that the ear bone discovered in the Himalayas was a piece of the tympanic bulla, believed to be part of an ancestral whale. Dr. Thewissen named it Ambulocetus natans, meaning a walking, swimming cetacean, as he believed that it led an amphibious life.
And I personally favor, although I'm not, it's not very well supported, we don't really know why there is this thick part of the ear. But I think that probably Ambulocetus was holding its jaw close to the ground and pushing it onto the soil that it was living on. And an example of an animal that has a similar type of hearing is crocodiles. They will actually sit on the ground, put their jaws right on the ground, and they will hear the footsteps of a potential prey animal.
About 50 million years ago, Ambulocetus natans lived near the edge of a shallow sea. With a heavy, massive body and short legs, it's unlikely that it could run swiftly after prey. Instead, it hid behind a rocky shade, placing its jaw on the ground and listening to the sound of an approaching prey. Then it ambushed the unwitting animal. This is how Dr. Thewissen believes that it caught its prey. Judging from the sturdy jaw and well-worn teeth, Ambulocetus natans is thought to have preyed on fairly large animals. The method of listening to sound through the jawbone is even more effective in the sea. Sound underwater is far more clearly conveyed by this method than through the eardrum. This incredible hearing system was subsequently inherited by the whales. By about 40 million years ago, ancestral whales no longer came up on land, but are thought to have lived near the sea surface. Their legs were no longer needed for walking, and consequently degenerated. Such cetaceans are known as Archaeocetus. From the sediments of the Awamoko ravine on a southern island in New Zealand, cetacean fossils of about 25 million years ago have been found in great numbers. By this time, Archaeocetus had already become extinct, and cetaceans similar to modern whales were beginning to appear. Dr. Ewan Fordyce of the University of Otago has been excavating fossils at this site and is continuing his studies on cetacean evolution. This is a fossil of a cetacean that lived about 25 million years ago. It already has many similarities with the present-day dolphin. What Dr. Fordyce noticed was that its upper jawbone sharply rises towards the back. This is a skull of an Archaeocete of 40 million years ago. The upper jaw of this ancient whale doesn't have the sharp rise. The fossil in the center is the one from 25 million years ago. The one on the right is the skull of a modern dolphin. The modern dolphin has the most prominent rise of the upper jaw. This peculiar structure is said to be important in emitting sound efficiently. Because cetaceans lack vocal cords, they vibrate the folds in the nasal passage to emit sound. At that time, the rising upper jaw serves to expel the sound forward. Moreover, the sound is compressed and ejected towards the desired direction by a special organ called melon. The rising upper jaw of the fossil of the whale 25 million years ago was a structure that developed to emit sound forward and to accommodate the melon. Dr. Fordyce believes that by this time, whales were already able to fine-tune the sounds they emitted and were beginning to echolocate, exploring objects with sound.
Any animal that can echolocate can navigate and find prey in the dark. Now we know that most of the world's ocean is dark water and there's a lot of food there. Echolocation allows them to invade deep waters, to invade dark waters. It makes them more versatile animals.
Not only did the whales heighten their ability to emit sound, they also perfected their skills at listening and analysing sound. The brain of the ambulocete was thought to be about the size of a ping-pong ball. But the modern dolphin has a brain as big as that of a human, although its physical size is about the same as an ambulocete. The enlarged brain further developed its ability to manipulate sound. The brain of the dolphin and human are compared. The coloured area indicates the neural network that sends signals to the brain. Dolphins lack the olfactory nerves. There isn't a lot of difference in visual nerves. But clearly the auditory nerves for conveying sound is much thicker in dolphins than in the human. The brain is like a computer. Dolphins and whales are perpetually transmitting an enormous amount of auditory information to their brain for processing. Cetaceans that acquired a highly sophisticated auditory function in this way proliferated to every corner of the oceans around the world and still prosper to this day. Whales migrate across the oceans, skillfully manipulating and analysing sound in a complex manner to communicate with fellow whales and to explore the deep waters. We now know that whales use sound to acquire highly sophisticated information far beyond our imagination. What appears to be a plain blue ocean begins to reveal an invisible, complex structure. The Institute of Cetacean Research in Japan has been conducting a study on the distribution of minke whales in the North Pacific. Their study has shown that the whale distribution is concentrated in certain areas of the ocean. Their 1996 study in the coastal waters of Hokkaido near Kushiro discovered certain areas where minke whales congregate. On checking the commercial fishing data, those areas coincided with points where large schools of sori were found, indicating that the whales gathered in those areas in search of food. But whales have no sense of smell. So how were these migrating minke whales able to know from far away where the schools of sori would be found? Even if they were to use sound, it would be difficult to identify the position of such small fish from a great distance. When the satellite image of seawater temperature is overlapped onto the map, the points where the schools of fish flow are areas where warm and cold currents meet. It has long been known that regions where warm and cold currents converge are lucrative fishing grounds. Recent studies suggest that transoceanic migrating whales like the minke and blue whales may be able to assess water temperature using sound. The logic is that although they may not be able to locate the small fish itself, they can identify certain sea temperature zones where schools of fish are likely to be found. Scientists too can now measure water temperature in the sea by using sound. This technology is known as ocean acoustic tomography. The equipment is lowered into the sea and sound is emitted. The speed of sound traveling underwater changes with even a slight change in temperature. By measuring how the sound travels undersea, the varied sea temperature distribution can be assessed. To calculate the complex temperature distribution from sound speed data, voluminous computation must be run on a computer. By studying the various paths taken by the sound through the sea, the sound speed data for each path is calculated to work out the temperature distribution. Satellite data can only tell us the sea surface temperature. But if sound is used, we can learn the ocean temperature too. The emitted sounds identified the many sub-oceanic zones of varying water temperature and located an enormous warm water mass. The whales are thought to explore the ocean in a similar manner.
The whale is moving through the fluid of the ocean, the liquid, which is changing in temperature, and there are currents, and there are places where there are large masses of food, schools of fish. So the ocean is not just this homogeneous, constant, unchanging mixture. There are all kinds of dynamics in the soft tissue of the ocean. Could it be that the whales themselves are using their sounds to probe the soft ocean?
Multifarious sounds flow in the sea. No doubt the whales identify their own sounds, the calls of their fellow whales, the sound of the waves and various other sound data. Then they analyze them in their brains and grasp or visualize the complex undersea world in their own way. This enables them to travel freely through the ocean from shallow seas to ocean floors. Some whales can indirectly tell us what lies in the depths of the sea that we ourselves cannot explore. The sperm whale is renowned for its diving expertise. Sperm whales can remain submerged for over 2 hours and are said to be capable of diving down to a depth of 3,000 meters in search of prey. No other living creature can easily manage such a vertical descent. The deep sea where the sperm whales hunt for food is less known to us than the surface of the moon. Many unknown creatures are presumed to live there. Strange deep-sea creatures appear at times in the abyssal waters that the sperm whale frequents. And the sperm whale serves as an unwitting courier of such strange creatures of the deep by bringing them up to the surface. This floating creature is a giant octopus. It's a Halophron atlanticus steenstrup that is said to inhabit the sea as deep as 3,000 meters below. From the leftover of the prey, we can vicariously get a glimpse of the marine creatures inhabiting the deep. In the old whaling days, remnants of numerous marine creatures appearing from the stomachs of captured sperm whales shed some light on deep-sea creatures. They were mostly squids. A male sperm whale consumes 1.5 tons of food a day, and roughly 90% of it was squid. It was the first time it became known that squids existed in such great quantity in the ocean depths. At the British Natural History Museum, squids collected from whale stomachs are preserved. Here is a preserved sample of a 2-meter-long giant squid. This squid is thought to catch its prey with its sharp hooked nails or claws on the suckers of its tentacles. Some squids became known to the scientific community for the first time only because they were consumed by a sperm whale. This clawed squid too has never been found to this day, except as a remnant of a sperm whale meal. There are still many creatures in the sea that only the sperm whales know about. On examining the head of a sperm whale, we find various scars. There are ring marks that measure 5 centimeters in diameter. On closer inspection, we find they are perforated rings. But how did such a majestic creature get such scars?
Van harte welkom bij Circus Grip.
In the seas around the Ogasawara Islands, pods of female sperm whales and their offspring arrive from summer to autumn. It was here that a rare scene was filmed. Several sperm whales were gathered around with their heads pointing to the surface, grabbing at something white. They appeared to be eating it. Leftovers, scientists found it to be a large squid. Perhaps the mother whale had been feeding it to her calves. The body alone of the giant squid measured 3 meters. The tentacles had already been consumed. Analysis revealed that it was an Architeusis, a type of deep-sea giant squid. The Smithsonian Institution has a preserved sample of Architeusis, which was beached on the east coast shore of the United States about 20 years ago. Because it inhabits the deep ocean, the giant squid in its living form has never been witnessed, and its ecology remains unknown. The largest of its kind reaches 18 meters in length, and its eye is said to measure 25 centimeters, the largest of any living creature. Even the size of the larger sucker could measure several centimeters in diameter. The suckers of the giant squid were taken out. There were sharp teeth lining the inside. The circular scars on the sperm whale were sucker marks caused by the giant squid. Dr. Clyde Roper of the Smithsonian Institution has been studying the giant squid for 20 years. He believes there's a great number of giant squid living in the deep ocean.
It's really impossible to know exactly how many giant squid live in the world today, but I think there are certainly millions. There must be millions, because there are perhaps a million or more sperm whales. Sperm whales feed on giant squid. And I think from some of the evidence we have, we believe that sperm whales could perhaps catch 1 or 2 giant squid a day.
Perhaps there's a battle going on every day in the deep ocean between the sperm whale and the giant squid. The giant squid is said to use its enormous eyes to capture even the dimmest light in the sea to search for prey. The greatest weapon of the sperm whale is sound. In the deep, dark sea, sound serves as a searchlight. The whale uses sound to read the surrounding topography and look for the giant squid. Some scientists believe that the whale shoots powerful sound at the squid to paralyze it. There must be many events beyond our imagination taking place in the unknown deep sea. But in recent years, we have been able to catch a glimpse of the deep ocean floor using a submersible. This current effort is merely a pinprick in the ocean, but even so, various discoveries continue to be made with each dive. The Japan Marine Science and Technology Center is using its submersible Shinkai 6500 to probe the deep waters of the Pacific Ocean. In 1992, it explored the sea floor off the eastern coast of Torishima of the Izu Islands at a depth of 4,000 meters. On proceeding through the lifeless, deserted seascape, it came across the white skeletal remains of a whale. The length from the head to backbone was 10 meters. Despite the scarcity of life forms on the ocean floor, strangely enough, myriad creatures like lugworms, lobsters and bivalves teemed around the skeletal remains. Further studies revealed that substances dissolving from the whale bones serve as a vital nutrient source for these creatures. The skeletal remains of the whale were providing an oasis of life that nurtured the creatures inhabiting the deep, dark ocean floor. And next to the remains was what appeared to be the ear bone, the tympanic bulla. This thick ear bone of the whale remains at the bottom of the sea for a long time without disintegrating. The tympanic bulla is symbolic to the life of the whale that has relied so much on sound and manipulated it with such skill and expertise. It must surely have conveyed the various events that occurred in the sea, the pulse of the fascinating creatures of the deep sea, and the diverse and dynamic true face of the ocean. The voices of the whales reverberating in the ocean. We have only just begun to lend our ear to their calls. The dolphin is asked to identify which of the two is the same. The dolphin chooses the correct pipe. This proves that dolphins have the ability to distinguish fine details by using sound. An experiment using sonar was carried out to find out more about identification using sound. Sound is emitted from the round black part. The same part also receives the sound reflected from an underwater object. A cage is lowered in front of the sonar. This is an image looking down on the pool from above. The straight line on top represents the edge of the pool. The square cage appears in front of the pool edge. By measuring the time and strength of the reflective sound, the underwater object can be identified. This is known as echolocation. Dolphins use echolocation to explore the underwater topography and to find food in the sea. Just as we have our bodies diagnosed with echograms, dolphins are said to be capable of seeing inside their fellow dolphins. This is a whale embryo. On closer inspection, its hind legs are visible. This shows that at one point in its evolutionary stage, the whale possessed 4 legs. Being mammals, cetaceans once lived on land. The key to solving the mystery of how the whale emerged lay hidden in the Himalayan mountains. About 50 million years ago, Earth had a temperate climate, and part of the Himalayas was on the edge of a shallow sea. And it was here that an unusual animal fossil was discovered. The fossil was discovered by the research team of Dr. Hans Thewissen of Northeastern Ohio University's College of Medicine. From the fossil, the team believed that the dolphin's echolocation ability can even identify fish hiding in the sand. The dolphins possess an even more amazing ability. On closer inspection, the movement of the fish escaping from the sand is slow and labored. It is thought that the dolphin directs a powerful sound at the prey it detects and paralyzes it. Of all the marine creatures, cetaceans are the only marine mammals that can skillfully use sound to such a degree. Why did only cetaceans acquire this special ability to manipulate sound? The answer lies in its evolutionary history. The creature weighed 300 kilograms. Because of its fore and hind limbs, the animal was presumed to have walked on land. At first, the scientists had no idea what species the animal belonged to. But as they continued their investigation, they realized that it was a whale.
At that point, when we dug up the skull, we transported it back to the place where we were staying, which is a little rest house. And I took some fine probes and some brushes, and I cleaned off certain parts. I cleaned off the teeth, and then also at some point I cleaned off the ear. And then I suddenly realized that the ear of this whale, of this animal, was the ear of a whale.
This is the ear bone of that creature. It's part of an ear bone known as tympanic bulla. It's very hard, intricate, and thick. This tympanic bulla is peculiar to cetaceans.